Our paper for the KDD 2018 is Feedback-Guided Anomaly Discovery via Online Optimization. This is a joint work by Oregon State University and Galois. Security attacks and data breaches have recently been escalated in such a high degree that we see such news almost every week. Suppose we have a computer that is affected by a security attack. A security analyst would be desperate to identify the attack as soon as possible. So he would collect all the activities occurred in the last couple of days and start analyzing them. The data may contain all the low-level system activities involving different types of entities like processes, files, and networks. For example, a process might be spawning another process or communicating outside of the system via some netflow nodes. Some process may be reading, writing, or executing files. This will create a giant graph, and here we are just showing a small portion of it. The analyst's goal will be to detect the entities that were part of the attack. Each entity is represented by a feature vector containing different types of event counts. The entities are then passed to an unsupervised machine learning algorithm called Anomaly detector. The Anomaly detector computes a score for each entity, where a higher score is assigned to the potentially malicious entities. This scoring mechanism gives a ranking over all the entities. Unfortunately, anomaly detectors in general produces a lot of false positives. For example, in the ranking, we can see the first attack entity is ranked at 99, and all the other entities before that are actually benign. A domain expert or a security analyst typically goes through the rank list from the top and examine each entity to verify whether they are actually malicious. This is a very cumbersome and time-consuming process. In real time, the analyst may not be able to go through all the potential entities before reaching an actual malicious entity due to time constraints or lack of resources. To resolve this issue, we incorporate analyst feedback into the anomaly detector after each entity is examined. In this example, the analyst will look at the top entity, which is actually a benign file, and the analyst will give this feedback to the anomaly detector. The anomaly detector will adjust its internal model parameters to produce new scores that would better align with the given feedback. So the ranking will change and the analyst will continue with the new ranking. This time, a malicious entity may arise at the top, which the analyst will detect quickly. This is an iterative process and can continue as long as the resources are available. In this work, we mainly focused on tree-based anomaly detectors, which have been shown to be the state-of-the-art in the literature. To incorporate feedback, we first transformed the trees into equivalent linear forms and employed online optimization techniques to adjust the corresponding parameters. The process is very simple, fast, and it requires no hassle of parameter tuning. For more details, please read the paper.